Primary School. So for this lesson, we'll still be continuing with the method of limit calculation. So we have revised 4 methods. So the first method, direct substitution. Second method, factorization. Third method, conversion between infinity calculation to infinitesimal calculation. And the last one, rationalization. But which one? Numerator, denominator, or both? So for that time we revised the numerator rationalization. This time again another 2 methods. So actually it's not exactly 2, but over here for this part, we'll still be continuing to revise here, okay? And we'll also have rationalization here, but it's not numerator rationalization. That's why I think this method is the actual method. Well, for this part, let's see. For question 1, limit n approaches to infinity. Square root n, they're over here. Okay. So what? Wait a second. Here you cannot straight away. Firstly, what is this indeterminable form? Sum in, okay, fine, square root infinity, you still can say. Infinity here, right? Infinity here, right? Infinity minus infinity. What is it? Cannot. So here is infinity minus infinity. This is why cannot. Then over here for this part, what you need to do is rationalization. Numerator and denominator are both. In this case, it's numerator. Numerator rationalization. Then here for this part, oopsies, it's not 2, it's an n. Now, for this part, what can we continue? How? So for this part, numerator and denominator both divide by square root n. So what's both is divided by square root n, this is what happens. Here, because 1, so this part, these 2 can cancel, so become 6i. While for this part, square root 2, because that here both have square root, so yeah. Then plus 3i over, wait, square root here 2, then plus 3i over n plus square root 2 minus 3i over n, like this. Okay? Alright. Now, over here, let's see. For this part, what happens is, wait a second, have you noticed something? So before you do this, you already know this part is a constant already, right? But for this, infinity, so let's first see for this part. Infinity, right? Plus together, so it's infinity, right? Another indeterminable form, infinity over infinity. What's that for? Conversion between infinity calculation to infinitesimal calculation. Get it? Okay. So for this part, now you can finally just use direct substitution. And then over here, let's see. So you don't have a limit anymore. So 6i square root 2 plus square root 2 square root 2 become 3i over square root 2. Wait, but we don't put square root at the denominator, so over here we rationalization. No, this is not about numerator denominator rationalization, okay? So here is 3, then here square root 2, then here 2. Like this. Get it? So it becomes like this, right? But wait a second. For this part, which formula did we use? So we use a squared minus b squared equals to a plus b times a minus b. Like this. Get it? Yes. Now over here, let's see for the next one. The next one. Over here, what is the indeterminable form? 0 OFC. Then over here become 1 minus 1 equal to 0. So 0 over 0. Then what are we supposed to do? So for this part, you have to use rationalization. But which rationalization is it? Let's see. It is denominator rationalization. So that's the extra method. The extra method is basically denominator rationalization. So here we got 1 plus x minus 1 plus x. Then here x and then here square root 1 plus x plus square root 1 plus 1 minus x. Like this. Then now let's see what happens if we sub it in. Here, of course, firstly, but before we sub it in, let's see. X, here still the same. So basically for this one, you also use this formula, okay? Then for this one, it becomes 2x. Then have you noticed something? You can simplify. So it's just simple as you just simplify, okay? Then you simplify here to here square root 1 plus x plus square root 1 minus x. Wait, is this, can you direct substitution now? Yes, you can. 0, 1, 0, 1, 2 over 2. 1. Wait, this reminds me of last lesson. Last lesson, during the last question, we used the numerator rationalization. And then at that time, we also got 2 over 2. Perfect answer. Same. Now over here for the third part, which indeterminable form is this? But wait a second. Is there a second method for this? We'll see about that. So what happens if we put the x below? So of course we cannot use, there's no such thing as infinitesimal who convert the infinitesimal who convert to the infinity, of course. But once you put the x below, it becomes like that, okay? Because that becomes both sides all divided by x. So still they are the same. But for this part, now let's see. 1 minus 1 equal to 0. Then for this part, x approaches to 1, so fill. Here, not fill. Here become 1 square cubic root become 1 minus 1 equals 0. So here for this part, it is 0 over 0. Okay. Alright, so for this part, let's see for this question. Wait, shall I do numerator rationalization or shall I do denominator rationalization? Or shall I do both rationalization? At the first sight, you say both rationalization, but nope, you can just do. Okay, so basically what you look at it, most people will first think probably both rationalization, as you can see, they are different. But until you solve this part, then you notice something. Okay, let's see. So this is what happens if I do both. This is what happens. But wait a second. So let's first put the denominator first. So here, since you need this part, 3x minus 2 minus 2x plus 1. So here x minus 1, right? X minus 1 shall we rationalize? Let's see. Over here 3x minus 2x, x. Then negative 2 plus 1, negative 1. X minus 1, x minus 1. No, I don't need to rationalize this part anymore. Okay? So, for this part, you have to use, so basically it's the a cube minus b cube, like this. Then, for this part, it is a minus b, a squared plus ab plus b squared, like this. Then for this part, let's see. Here, what is this part? Because then you already have this part. So what you need to type in this part, whereas it is cubic root here x bracket x minus 2 bracket square. Wait, it's 3x. 3x. So this one needs to be a bit longer. So here minus 2. Then after that plus AB. Like this, and then so just mind that here don't have enough space, okay? So here you still have plus cubic root, then here, so for this part become, so wait, become 2x minus 1, then here holding bracket, right? So you need square, because without the square this part is wrong. Okay, now over here for this part, so the line here. Now, as you can see, these two can simplify already. That's why I told you, don't need to have both rationalization. Only need the denominator rationalization. If not, you're giving yourself more trouble. Okay, so over here now, since it's only like that, so it becomes, here simplify. Then here 3, then here 3x minus 2 square plus cubic root 3x minus 2, and then here got 2x minus 1. So over here basically so here then here 2x minus 1, like this. Okay, then here for this part you still have one more, whereas it is plus cubic root, basically this part, like this. Okay, alright, now over here for this part, let's see okay, confirm already. This is, you can direct substitute. So over here become 1 plus 1 plus 1 equal to 3. So 3 is the answer. So then I'll give a quick summary. So for this part, basically here you use a numerator rationalization. Then after that you use the conversion from the infinity calculation to the infinitesimal calculation. Whereas basically that's what we learned last lesson, exactly the same method as the last question. And then here, this is what we got. As over here, this is acceptable, but that is rationalized here. Basically, the rationalized also you also call it the same. And then for this part, new method, denominator rationalization, and then after that over here, got the same answer as this. last one and last time. Then for this part, you do denominator rationalization because if you do the numerator rationalization, it's just going to be a waste of time. So now last but not least, thank you for your watching.